As we saw in the finite element method, we need to divide the domain into little chunks called elements, and the solver will use the corresponding nodes to write algebraic equations relating nodal displacements. I will go to the project page, right-click on Model, and select Edit. Say starting mechanical, and this will take a minute or so. When it loads up completely, you should see a tree like this. Highlight mesh in the tree and click update to get the default mesh. I usually like to see what the default mesh is like. And we don't quite need, at least for initial analysis, as many divisions through the length, but we might need more elements through the thickness. So let's control that. So first I will control the number of divisions along this the length of the cylinder, and to do that I will highlight mesh in the tree and I'll say mesh control, sizing, and then I will select the face selection filter here, and I'll select this cylindrical face and the inner cylindrical face also, and then click apply. So this sizing is applied to two faces, and that sizing, so the length is 4.2, so I'll say equal to 4.2 divided by 6. I'll start off by just having 6 divisions along the length. And I like to start off with a coarse mesh and then later on do a mesh refinement study, which we will undertake. And then I can say update. And if I highlight mesh in the tree, I see that I have now only 6 divisions along the length. And then if I zoom in here using the middle mouse wheel and translate by holding down the control and using the middle mouse button, similar to space claim, I will see that I have only one element through the thickness, which is usually not good. And then I can look at the nodes. So if I select nodes and I see that there is a node here, there is a node here. Now, if those were the only 2 nodes, it would be a linear interpolation. So you could have only a linear interpolation of displacements across there, but it also puts in a mid-side node. So you'll have a quadratic interpolation through the thickness with one element. And in our case, that might be adequate, but it is recommended that even with the quadratic elements, because we have the mid-side nodes, you'll see that there are mid-side nodes all over. So there is within each element there's a quadratic rather than linear interpolation, which is good. As we saw, as the polynomial approximation gets better, the errors get lower. So let's increase the number of divisions through the thickness to at least 2. And I had to ask an ANSYS engineer how to do that. So I highlight mesh in the tree, come to sizing, and under use adaptive sizing, say no. So turn off adaptive sizing, and that gives you this option to capture proximity, which is the option you use to capture gaps. Say you have a gap between 2 holes, a small gap. So you can control the number of elements through there. So I will say yes to proximity, and the number of cells across gap, I will leave it to the default. And there's a minimum size, and I'll leave that as the default too. And I'll come back, I'll come and say update, and you can see the effect that had, and you can keep changing, you can keep changing that. Now I can also get, this is a regular phase, it's just the analyst, analysts of a cylinder. So I will, I can put in what they call face meshing to get a more regular mesh. So I'll go under control, mesh control, face meshing, and I'll apply it to this face and the corresponding face on the other side, and I'll say apply. And I'll say update. And if I go and look at the mesh on the face, you know, I get a nice regular mesh. So these are, you know, as I've discussed elsewhere, these are elements of good quality. We won't look at the element quality here. We also get this warning, and it's a good idea to take warning seriously because they can come back to bite you in uncomfortable places. So it says some local face element sizes are larger than the global maximum size. This can cause bad quality elements. That's because, so we have this face length is pretty large, so that's why you're getting that error. And so it says, you know, basically that length is larger than the default max size, which is 0.4. So if I change the max size to 0.8, before that, look at the outer circle here, okay? Look at the size of that. And now when I come and change this to 0.8, you see that outer circle reflects, shows you what is the, you know, what does 0.8 look like, and you see it's larger than this longitudinal length. And if I say update, okay, that warning goes away. And in the process, we also discovered what that outer circle represents. It represents this value here. And so I can come in here. So I've marked out the points at which I want ANSYS to calculate the displacements. And if I go in over statistics here, I have about 2,400 nodes, 2,400 odd points at which I want ANSYS to calculate 3 displacements. And because at each node we have displacements in X, Y, and Z directions. So we are asking ANSYS to calculate 3 times 2,400, about 7,500 values while providing this mesh. That's all there is to meshing, so I'll save the project.